We'll do one thing. I will write M1 mass. This M2. If I make it this fixed here, it's asking the frequency of oscillation of this. Then this block will have time period. This will have time period. So what is the frequency given by F1 equal to 2 pi K by M1? Each block will have the same frequency. So what is the frequency? No. So it should be equal to this much. Agree this M2 is fixed. M2 is not permitted to oscillate. Okay, second situation, the M2 what happen can also oscillate. In that case, so what should be the oscillation frequency is asking. Then is asking further the ratio. Initially, so I'm going to displace them. Okay, I'm going to move all the blocks. This M1. You try to see the way I'm displacing it. This M2. Sir, why you are displacing? The way the arrows are given. Based on that arrows is what I have displaced them. So both are having same spring constants are same, K and K it is. No. So let this be X1. Let this be X1. I'll show it here. Let this be X2. What is the state of this spring? Elongated or compressed? Which spring? The left spring I'm asking you. I think it's being elongated, no? So therefore, all the spring force will act in this direction. The spring force here will act in this direction. What about this spring? The spring is compressed. Then how the spring force should act here? Okay, we are safe. Yeah. I take some green color one. I know how the spring force should act in this direction. No, I'll show it here, or else. Okay, this will be. Because what is the compression of the right spring? X1 plus X2. So the next spring, the spring force will be so what is the acceleration of this? Let it be A1. So acceleration of this be A1 and the acceleration of this let it be A2. Okay, what we have to find out the frequency of oscillation. How do we can bring this? Okay, let me directly look at the block M2. M2 A2 should be equal to K X1 plus X2. Shall I write 2 Y2? Both the forces due to left and right spring will be acting on it. Agree this? This is a compressed, this is elongated. Elongation. This spring is compression. So therefore the forces should be like this. But what is the displacement of block M2? x2 or x1? Look at the diagram and answer it. What is the displacement of block M2? Is there no? So it is like x2, I assumed it. But what we have x1. How to eliminate x1? Are you getting? So you have to straight away ask yourself a simple question like, acceleration proportional to negative of displacement is what SHM. Okay, fine, we have, but this x1 should be eliminated. X1 in terms of x2 should be brought it here. And what is the net force acting on system? Will be 0. Net force acting on system is 0. So therefore, center of mass will not shift. Summation of Fx 0. Then delta XCM should be 0. So what is the delta X? What is XCM? Delta XCM, we'll write like this: M1 delta X1, M2 delta X2 plus M1 delta X1 all by M1 plus M2 plus M1. Can you recollect center of mass concept? Okay, look at the direction of X1. Delta X1, I think look at the diagram in the question, the diagram here. The oxygen molecules are given displacement towards right, towards left. Carbon molecule is given displacement towards right. So therefore, this x1 will be positive, x2 will be negative according to sign convention. So this is 0. Finally, 0 equal to so therefore this will be 2m1 delta x1 equal to m2 delta x2. What is the assumption we made? Displacement. This is x1, this x2. Let me replace that x1 there. I'll substitute this in, put 2 in 1. I think that this is the part A. This is the part B. Okay, put 2 in 1. Okay, after putting 2 in 1, so what do we get? M2, A2 is equal to 2 K, X1 is M2 X2 by 2M1 plus X2. Okay, now solving, so we have everything in terms of this. So A2 is equal to 2K, 2 get cancelled. So this will be K, M1, M2, M2 plus 2M1. So what is the time period of oscillation? Directly, let me write frequency. F equal to 1 by 2 pi, no, it is, I think, yeah. 1 by 2 pi K by this is the in the second part. I'll write FB and FA. This ratio is what he's asking. So what we have like this, if reduced mass only, say with the help of that, sir, where is the reduced mass? I think the similar approach is what I applied here earlier. The effective mass of system has to be replaced here. Look at what is the mass. This will be 2m1. And these together, I'll place 2m1, then I'll replace. Then I'll make this together as 1, 2m1, then m2. But sir, the formula is not like that. That's why it's not that something reduced mass formula you can apply it. It has to be derived. Okay, I think we have space here. Okay, it's asking ratio FA by FB. Then you solve it further, this one. I'll scroll down. We take the next question.